continuing our discussion of groundwater flow and trying to get an equation for it, let's consider a very small little cube within an aquifer, and we'll call this some sort of elementary control volume. And we want to relate the flow into and out of this cube with the constitutive relationships that we know about water, namely how water flows in response to a head gradient, Darcy's law, and how much water is released from storage given a change in head in the aquifer as expressed by, for example, the specific storage. So let's get some flow into and out of here. I'll have flow across this plane here. We'll call this QX. In the X direction, we can have flow coming out here, QY, and then we can also have flow across this plane here, QZ. Now, the change in storage inside of this box is going to be related to the difference between the QX coming in and the QX going out. So the out minus the in here. And we can describe that mathematically using partial derivatives and describing the change in space here. So let's see here. And we're going to add it up in each direction. So we're going to consider the spatial gradient in flow in the X, the Y, and the Z direction. Make that a Y. So this is describing the output minus the input. This has to equal the change in storage, or the change in mass if we were to look at the density and the volume here. And we can relate this to the properties of the aquifer. If there's an increase or decrease in storage here, it must mean that water was added to or released from this control volume. And that has to be related to a change in the head of the aquifer. So the relationship is that these fluxes, the in and out, how their relationship to the change in storage is going to be related to the specific storage, which describes the volume of water gained or released per volume of aquifer, per change in head, times any change in head in time, just like this. So this is the start of a generic form of the groundwater flow equations given this particular control volume. Now, there's one other substitution that we can make here, and that is that we know how to express QX also in terms of head, right? We know, for example, that we could substitute in Darcy's law in this equation. And for example, in the X direction, we know that the specific discharge Q sub X is going to be equal to the negative hydraulic conductivity times the spatial gradient in hydraulic head in the direction that the flow is occurring in. So in our next video, we'll substitute these terms in, and you'll see the full expanded form of the groundwater flow equation. And then we'll make some simplifications that make it a little bit less of a beast to deal with and make it mathematically quite a bit simpler.